Good afternoon, everybody. Thank you for joining us here for the Gotham project call. I'm Cole Miller here with America Makes. Shortly, we'll be turning it over to John Martin to kick this off, but just for some initial housekeeping, if you have questions during the webinar, please go ahead and post them in the chat. Just know that if we're not able to address your question during the meeting, we will be collecting them and then answers are posted publicly on our website. And there's dates in the RFP by when you'll need to get questions to us, as well as when we will have our answers posted. So we're going to go ahead and kick it off. So John, I'm going to toss it over to you.
All right, thanks, Cole. Good afternoon, everyone. Thank you for joining us on this kickoff for generation of technical data for high-strength aluminum alloy material, or otherwise known as GOTHAAM. So we'll get into it. A little bit of the background. So for those of you that were on the prior call and have noticed on some of our prior project calls as of late, a lot of these opportunities are being generated out of the Joint Additive Manufacturing Working Group, also known as the JAMWIG, sits under the DoD or the DOW, OSD, but comprised of a lot of different SMEs, AM stakeholders within the DOW, identifying materials, needs, processes that could help the mission of the warfighter. So this program is similar in nature to previous programs that we've had, JMAD being one, Gamut being another, building out allowable data sets. So we've also had a few others as of late. That was on proliferation of material data sets that was nicknamed pods by some of the members that focused on some materials that they weren't novel, but they're definitely kind of novel. So Ti-64 was identified as an existing material, very prolific, I guess, through the DoD and other use cases throughout industry. And that's one of the big overlaps for this one. Not that it's going to be specifically the same material as aluminum 7075, but an equivalent. So the material could be, I guess, relatively novel, but it would have to be ready for an allowables dataset generation, which means it would have to be relatively well understood, at least by a few folks. But the aim of this, I don't want to say it's creating or coming up with some sort of, or leveraging an existing novel alloy, but I guess depending on what lens you're looking at, it could be seen as that. But basically, it's something that can be utilized for aluminum 7075 at the T73 temper. So, and also with performance matching the specs AMS 4141, which is for the forged form of 7075. So this is the primary emphasis of this project call. There's more to it than just your typical like mechanical behavior, though, since we're dealing with aluminum and in that specific heat treatment that was developed to address stress, corrosion, cracking, and corrosion issues with this alloy. So if we look at kind of a little more of the specifics of what's being asked for and what are some of the expectations, or in this case, some threshold values listed, is one thing is a PCD or a process control document is to be developed. And the initial data set, so similar to what was on I think it was AIM that came out a little while ago for stainless. But for this project, and I'll get into it in a couple other slides, but phase 0, it's being called. So kind of, if you want to call it a pre-qualification, leveraging the document, or more than leveraging it, following it in accordance with EN FSB 2501, which is a flight systems bulletin out of AFRL. And it'll be linked PDF form on the website. It's already on, like I said, I think it's the AIM for AM, but it's basically, if those of you familiar with MMPDS, there's CD basis for additive, and then there's S basis. So it's kind of like an S, but a little, it's different. It has a cross comparison of some of that. A little, it's was born out of, I believe it was AFRL, focused on airworthiness. So it addresses some additional elements more specific to flight worthiness, but it's along those lines. Very useful document. Provides, I think, a lot of insight of what the needs are within some of the stakeholders within the DoD. And it gives really good guidance, I think, for the performers, on test matrices, test plans, on what to focus on right away to get started. So that document it's a requirement to utilize that as well before generating the full allowable data set. So if we look at the requirements for at least some of the mechanical properties, there's tensile, yield, and then elongation. So there's threshold values, objective values. And this is based off of the A basis values for aluminum 7075 T73. And this is to the spec AMS 4141. So as you can see, threshold value for tensile 66, yield 56, and then elongation 61. The objective values a little higher, obviously, but that's the goal for the allowable data set. And then also, let me see if it's on this next slide. I don't know. It might be coming up. It's definitely listed in the RFP quite a bit, but it's mentioned on this bullet point here. So this will also include, at minimum, development or developed material shall exhibit equivalent or superior IGC, SCC, FCGR, so stress corrosion cracking, intergranular crack growth, and fatigue crack growth rate. So all the different things around corrosion and cracking, because this material, and it's a little kind of explanation of it's in the RFP, was susceptible to stress corrosion cracking due to just being in corrosive environments that may not have been super obvious. This goes back, I don't know, 60s or 70s or something like that, quite a ways back. But we just want to make sure that the performers are well aware that this is not just getting a material, an aluminum that's, basically like high strength, pretty good ductility. It has to have really good performance when it comes to corrosion and crack resistance performance. So this project is broken up into 2 phases, and this is required, but it also helps, I think, the performers to break this out, the workout, instead of just jumping straight into, trying to print a bunch of coupons and test them and stuff like that. So phase 0 is laying the foundation essentially before you do like a full material allowable data set based off, say, MMPD SCD. So develop a feedstock spec, process specification, material specification to support your qualification. You need a material spec anyway. It's got we want it to be in alignment with MMPDS. Perform a detailed mechanical and microstructural analysis of the laser stitch zones. So this isn't, you know, super well defined or spelled out anywhere, but we don't want it to be just kind of an afterthought. So we do want that to be studied and well understood. And this is going to be for the multi-laser systems. So I guess I'll mention too that this study is to look at this is material allowables generation across 3 different size laser powder bed fusion printing platforms. So small, medium, large. Small would be like a single laser, uh, medium, and the specifications are listed in the RFP. Um, would be, starting to get into your multi-laser, and then the large class would be definite multi-laser. And then there's the footprint. I don't know if it's 600 by 600, what's listed there, but it's all spelled out in the RFP. But I want to make, and I think it's coming up on some of the next slides, but I wanted to make mention of it now just to provide context of quantifying the laser stitch zones as best as the team can. Leveraging work that's been done in this area as well. So this is something that is important in the community. I'll call it, it's a thing that exists, and it's going to exist more, especially with multi-laser, and the more that gets adopted and more common that becomes. But we don't want to just assume that, the algorithms or different things that are being established in the process and just kind of, I don't want to say we do want to trust them, but we want to understand them. And we want to be familiar with them. So that needs to be captured. Execute a comprehensive powder reuse study to determine the effects of feedstock reuse on the powder chemistry, morphology, etc. So definitely want to know basically a good approach for the powder reuse strategy for this material. And then the heat treatment is going to be critical. So the heat treatment is going to have to be developed and optimized during phase 0, obviously prior to generating the material allowables. They would have to come from whatever that final optimized heat treatment is, as well as the material spec, process spec, PCD. So PCD, like previously mentioned before, is going to need to be developed for this project, and that will also include the heat treatment of the material to get it to its final product form. I mentioned the machine size variations, and then material characterization inspection will be performed according to the flight systems bulletin that will be provided in a link. So that's discussed on page 7 of the RFP. So if we look at phase 0 continued, so there's another document in there. It's not required to follow, such as the previous one that spells out more of, the test plans to follow, orientations of parts, different things like that. This one, I think, is just a good reference document. EZSB 13001. So this is something that I seen come across on some other projects, and it was seemed to be just another really good piece of information that could be referenced out of AFRL, I believe, another bulletin, but titled Requirements for Substitution of New Material, Product Form, and Processes for Aircraft Metallic Parts. So once again, just additional support information, right? It's just to provide maybe some more context. So it's definitely not to, say that you got to follow everything in there, or you don't even have to really look at it, I suppose. but it's something that I think would just help provide perspective. They do mention this material in there for some of the examples. I think it just gives a good vantage point of DoD, what their needs are, and where they're coming from, really. So another thing that we want to make sure is done in this project is conduct a systematic evaluation throughout the entire build height to understand any potential material properties that you would have in the vertical direction of the build, instead of just understanding coupon generation in the, say, first half or 3/4 or whatever. We want this to be characterized through the full build height of the machine for each type of machine. And then all the data sets that are generated on this project are going to need to be in a template for the workbench for additive materials. So this was something that we've introduced on some of our previous projects that have come out recently. We'll provide a template for that for the project teams, if whoever's awarded, or I guess in this case the one team. And then within 30 days prior to the completion of phase 0, the proposer will meet with the government advisory team on the readiness to move into phase 1. So we want to make sure before the full material allowable data set generation event takes place that everything checks out, everything's good. The test plans were followed appropriately, especially to that pre-qual bulletin. And then also the stress, corrosion, cracking, more so the corrosion effects and everything that were, characterized sufficiently before moving forward and investing a lot of time and effort and money. So when we look at phase 1, this is where it's going to go into generating the full material data set, which the data set generated in phase 0, it'll contribute to this most likely if done correctly. So it'll already be started using the PCD and heat treatment developed in phase 0. Going to move into the generation of the full data set. And this is going to be across the 3 different AM machines, increasing in size. And another thing that we're interested on this project is to capture the equivalency between the different size classes of machines. So all the information is, as far as the data sets and the allowable generation, is going to be, essentially pulled together to come up with a value based off of the different machines. However, when you're generating the data, we want the team to capture basically the material performance coming off of each different size of machine. So that's all recorded and documented, whether it varies or not. If it doesn't vary, great. If it does, we definitely want to know what trend occurs, what it looks like, at the very least, to just have an understanding of that and an awareness. But the better that can be captured, is definitely going to be seen as a positive, but we want to understand that. Once again, phase 1 data sets will need to be formatted to be incorporated into DOW's WAM database. And here's the descriptions for the small, medium, and large printers. The medium and large are going to be required to be multi-laser. So if you can imagine, the medium would have maybe like 4 lasers on it, and then the large would have a bigger number. It depends on what what OEM you're going to go with, but this is the categorization of the different size printers. We don't want to give examples of different manufacturers because that's not the focus of this. Is to study a specific OEM but it's more to understand across what the existing defense industrial base has and understand it more for an aluminum material such as this. And also incorporating those different size machines, but larger parts are very important as well, especially for this type of material. So test plans to include specific locations and overlap requirements for stitching, and that's going to have to be approved by the Government Advisory Board. So there will be a Government Advisory Board similar to the project Delta Qual 2.0 that's going to be, which I think it's probably on the slide here, but it's definitely spelled out in the RFP as well. It's going to be gathered by DoD, JAMWIG, that team identified, and then they're going to be, think of them as support, feedback, oversee the project, make sure it's in alignment with DoD needs. So if we look at phase 1 continued, all material testing and characterization shall be performed in a NADCAP or ISO 17025 accredited laboratory or equivalent. So there may be some, I'll say, unique exceptions, but ideally we need all the test data to come from labs that are NADCAP or ISO accredited. Proposal teams are encouraged to leverage existing data from ongoing or previous American Makes projects. And then, so that could be, anything from data management strategies to lessons learned, printing, want to print a few extra coupons or a few extra builds, especially when you're doing a lot of different types of heat treatment. You can have some issues with your heat treatment providers, might even lose a build. So, I mean, those are things that you could definitely learn some hard lessons easier by leveraging some of the future work, understanding some of what the earlier project teams went through and some of these efforts. So I guess that's one thing I'll make mention of is, yeah, be careful with your heat treatment, and make sure that that's well defined, and to save your, some of your builds or parts, make sure they're all utilized well. So material property data sets we'll use. Yeah, so this is the WHAM template. This will also help facilitating with core. Although the data management strategy, we would recommend that it's, we don't have anything formal at this point, but this is one of those projects that you're generating a lot of data. It's going to be for material allowables. So you're going to want to have a pretty strong data management plan. So either like a software you're using or an approach, templates. We have a lot of good resources that we've been generating. Our project team at Penn State, ARL, recently, I think it's finished, but I know the data templates and the recommendations and things like that for data management, especially for projects like this, are in core. Can't remember exactly what the name of the project is off the top of my head, but we can provide resources for that. But we would definitely say you want your information to be able to go into the WHAM template, and that'll help with core. But we also want to make sure that this information is as usable as possible for our members as well, I guess is what I'm getting at. And a lot of that comes down to data pedigree. They need to see that the data generated from the material properties is trustworthy. So government advisory board will be created for the project. So this is the one I was just discussing a little bit ago. So that's going to coordinate with the government program office and then the JAMWIG team under OSD ManTech. And that's going to select the members of the advisory board. And then the advisory board's going to I want to say they're not going to work with the project team, but they will definitely be overseeing it. The project team will have to um, actively, get the input of the government advisory board. And then the proposer team should include weapon system platform OEMs and/or organic sustainment organizations to ensure transition of the programs. So this is basically to make sure that you have somebody on your project team that is going to make sure that your approaches, your procedures, the things you're doing on this project, in addition to some of the other layers that we have, but would give you insight to, let's say, a prime, for instance, or whatever, and give you their perspective of, what you guys, the approach you're doing is in line with our expectations. So one example I guess I'll give, I hope it's a good one. I think it is for this potentially. In my mind, it's always kind of important, I guess, but it's like, what layer thickness are you going to use? We could always go lower on the layer thickness, I guess, if we want to try and, increase the odds of getting a good material out of the printer, but it has to be big enough that the production rate is going to make sense. So I don't know what it would be. I have no idea what it would be for this, but I know that was something that came up on JMAD. The original layer thickness proposed, I believe, was not big enough for at least one of the primes. I don't remember how all that shook out, but I know it was increased due to input basically from, okay, if we're going to use this, we got to be able to up the layer thickness because this isn't at production level. So that's something, one thing to consider. But you can, obviously having somebody like that on your team could provide really good perspective on things like that. So if we look at funding breakdown, topic awards. So one topic, one award, the amount's going to be 5.5 million. Cost share requirement is going to be 50%. So if we look at the period of performance, technical period of performance is going to be 20 months. And then final reporting phase, 3 months. So the total period of performance is 23 months. And then if we look at the schedule, project call was announced yesterday. And then questions are going to be due 2 weeks from yesterday. And then we will give ourselves 1 week to answer the questions and then have them posted back out to the membership. We have some dates for NDAs fully executed with NCDMM, membership agreement paid in full, all on May 18th. And then the big, probably the most important date for this audience is going to be when are the proposals due? They're going to be due on June 2nd, no later than 5 p.m. And then anticipated notification for the winning proposal team, July 6th. So if we look at membership eligibility, it's going to be standard with most of our projects. Some of them are more limited. This one's standard. The project lead it's required that the project lead be an America Makes member in good standing, also paid in full by May 18th. The project team members do not need to be America Makes members, although it's highly encouraged that they do so. And we don't just say that because from our perspective, we say it from the team members' perspective, because if you are an America Makes member, you'll have access to more of the project information, meetings, calls, discussions, probably especially with the government side. You get some great perspective on some of those calls or a lot of those calls. So you get great value out of that, being able to fully engage in the project and learn from it. So maybe a prime learning from a small business or a small business learning from prime. So, we get a lot of those interactions on these projects. So definitely something to keep in mind. We have a lot of cost share opportunities also that can be leveraged for those of you that are not members. So reach out for ways to take advantage of that. And then if we look at some of the other eligibility requirements, foreign nationals that are participating on this project, that all needs to be reported to the American Makes Program Management Office, which is in the government. So us to them as soon as possible. So in advance and approved in advance, but to stay in contention for possibility of, winning a proposal, we need to be notified of that as soon as possible so that could all get approved. There's no guarantee. And then foreign nationals from the following countries are strictly prohibited. So we have a long list of countries that you cannot have any foreign nationals from there on your project team. And then execution of activity outside of the U.S. in response to this project call is discouraged. So if it's deemed, I'll say required, or it has to be done because of the, material supplier or whatever, that's something earlier you tell people, the better. And typically that there needs to be like a good reason for it. It's, it can't be just, we're going to do some work outside of the country because, we have a partner over there that we like. But if it's some sort of unique capability or, like I said, a material supplier or something, then, sometimes that happens and it's unavoidable. We look at deliverables and reporting. So deliverables table is in section 2.4 within the RFP. Plenty of things listed in there, like test matrix plan, different things like that. And then also programmatic as well. And then for a list of the reporting requirements, you can see further on down the document, section 4.3 is all listed. And then if we look at the evaluation criteria for this project call, so the technical approach and methodology is going to be 40%. Technology dissemination impact on the U.S. supply chain is going to be worth 25%. Program management approach is going to be 30%. And then the cost is going to be 5%. So there's sub-elements within each one of those four categories. They're all listed in detail in the RFP in section 4.1. We encourage you to go look at those and make sure, they're all being addressed in your proposal. And then, like I said, for this project call, you're also going to want to demonstrate that you are going to manage the data very well. So here's some information on proposal and contracting information. And then the teaming platform. So teaming platform is a tool that we've introduced several months ago. If you go to the RFP webpage, scroll down, there's going to be the button to download the RFP. If you look over to the right, there's going to be a little box, I guess I'll call it. It says interested in teaming. So if you click on that team up button, that'll open up a pop-up window where you can put in your information, types of partners you're seeking, your role in the project, basically what you could bring to the table. And then what we do with this information is it gets incorporated into our America Makes member portal. So it's not like it's just out there for anyone to see. You got to go into the member portal, log in. You could go in there, though. You could look at the project teaming submissions for each project call and then see who had entered their information and what they're looking for as far as who they're looking to partner with and what some of their strengths are that they could offer to the project team. And it's a really great tool that we have developed to help our members quickly team up with partners and I'll say get that coordination done as quickly and efficiently as possible so the proposal teams could get to work on the proposal. All right, so I think yeah, that was the last slide I have. So now we're ready for any questions.
Hey, John, it's Greg. Can you hear me?
Yeah, hi Greg.
So I put a comment in there. So you have, after 30 years of developing casting alloys and 10 years of AM alloys, at least in castings, you have got to have a good casting process that will make the applications you want to make before you go to design allowables, right? You have to know it will, because you tailor your design allowables towards the, at least in part, towards the applications, right? And you're not going to do design levels unless you can make certain parts that you want, right? That some of that is you know specific to a particular company, right? So I guess the comment and the question is, maybe I missed it, but you just don't want somebody to go do design allowables and then you find out, oh man, there is a little bit of a window in laser powder bed fusion. You don't want them to say, oh goodness, now we can't make the parts we want to make, right? So
Mhm.
what's your risk mitigation for that? Because, at least at Honeywell, we spent a good year making sure we could make the parts before we created the 10 sets of design allowables we have, right?
Mhm.
So how do you get around
So
that?
so you're saying kind of like part limitation based on like laser powder bed fusion?
Yeah, because is this later Predator fusion? This is for that.
Yes. Yeah.
And so, yeah, I mean, I wouldn't assume it can make the parts that everybody wants to make. And then you're going to tailor, a couple of things. One is you're going to tailor um, what you test you go after, fatigue, creep, fracture toughness after the applications, right? Now, 7075 typically has a lot of airframe applications, as a former, Alcoa guy, Davenport, Lafayette, right? But you're going to, I wouldn't assume that the parameters that somebody chooses, the scanning parameters, the processing parameters, are going to make all shapes, John and everybody. So you have to have a feel, in my opinion, for what the geometries it can make. I mean, we sure hell wouldn't have done it. Now in castings, you really can't do that. You'd be at, or in plate stock like 7075, something like that. At Alcoa, we would never have done it. We would have known what we could make, and then we would have created design allowables. Right now, laser powder bed fusion is much better. It is much more versatile by far. But I still wouldn't assume it can make everything. You know what I'm saying, John and everybody? So how are you going to deal with that? Unless maybe there's
Um,
alloys out there that already been proven, or maybe that's a criteria by which you judge the entrance. But if a university comes in there and says, "Yeah, I'm going to do these scan parameters," and then they do design labels on something, and you can't make anything with it, what good is that? I think it's a good program, but that's
I think
that's
I
a
see what you're saying. Yeah, kind of
yeah.
the incoming maturity of I'll call it the OQ maybe. Yeah,
Well, you
so
got to know what parts
ideally
you can make with the scanning parameters. I mean, you have
I
to.
I think well, I think if you could yeah, I mean, depending on how complex you get, um,
Because
but
John,
I
if
I
you're,
think
I know
it
I'm jumping in here, but if you're going to make just plate stock, forget it. Go to Davenport for rolled product. Go to, you got to make some shapes with this. Otherwise, you're going to buy plate. You're going to buy extrusion stock. You're going to buy forgings from Cleveland, right? So you got to
mhm,
make some shapes. So
yeah.
what shapes can you make? That's the first question.
I think it would be a lot of different shapes, but I think the ideal proposer, and I know we have some folks on the government team, but I'll just kind of give my
Sure,
perspective,
sure, sure.
is the material process combination is going to have to be pretty well understood. Now, whether it's shared currently, you know, maybe not, but yeah, whoever's at least in my mind proposing to this, they're going to have a pretty good understanding of what the parameter set is that they want to use.
And, and they have to be able to justify. Now, it's
Yeah.
a real open, honest question, John, because Honeywell doesn't use a lot of 70, 75, 70, 50. So, we're not bidding,
Mhm.
but I'm just gonna say, I would think that proposing team better know what applications and better be able to prove that the scanning parameters they're going to select can make those applications. Now, maybe it's so versatile that it doesn't matter. One parameter set will make everything, but that's not my experience in most alloys, including laser powder bed fusion. Just as an example, right, John? Everybody?
Yes. Yeah, I get what you're saying. Yeah, I think it would be expected, yeah, that they've had some experience in making parts. Maybe not got to the point where they have a whole, a full statistically based data set presented at the time, but yeah, definitely would want to have a pretty mature material process combination, and then in addition, understanding, you have that heat treatment element in there. So it's not like there's no room to be able to do that, but a lot of that would have to be pretty well fleshed out. Not a ton of developmental work. Brandon, I see your hands up.
Yeah, you able to hear me, John?
Yes.
Okay, so I wanted to, I think Greg makes a great point. Number one, I wanted to ask you and kind of chime in here. I know at one point we were talking about requiring cognitive engineering authority or a person who understands the associated applications with the material system. That's in here, right?
So yes, we're asking for someone on the project team to be, you see the exact language here, but yeah, for a weapon systems platform.
So I think in that capacity, right, to close the loop a bit on what Greg brought up, which I think, again, very valid and important point. I think it's envisioned as we put the opportunity out to the community that the team and their response would be addressing that through that partnership, right? Through that partner's role in the response to bring that associated application understanding along with the geometric considerations for those components. Now, he also mentioned the testing. I can see how a partner who understands the intended application bringing some requirements, but that's also the reason why we included the flight safety bulletin as well, right? To level set on what's the expectation in terms of the test matrix and the types of testing that are anticipated. Does that make sense, John? Or did I capture everything there? Okay. Does that
Correct.
Jive? Okay.
Yeah. Yeah. So yeah, looking at things a little more along the lines of performance specific testing. A lot of that's captured in the prequal, the flight bulletin. But then also what's spelled out for the corrosion and fatigue and different things like that. Um, so yeah, good points. Great.
And just one other thing, John. So, and Brandon, everybody, and once again, I don't think we're going to bid, but I just would just say, this information for you guys, right? That'll certainly take time. If say you have a major in this thing, Northrop, Lockheed, Boeing, whoever it might be, right, or others, and they say, okay, we want these 10 part types, right? Then I would think there's got to be something in the program that says, okay, now we're going to make some of those parts to verify that these parameters will make all these part types. Because otherwise, you don't know how to set your design allowables. Now, C and D maybe, but there's some time for that. Now, does the program have to do that? Not necessarily, but I do think ideally it would have some time to prove that it will make those parts. Now, if somebody's coming in already and they go, yeah, this is alloy X and we've already made these parts and see how they look pretty good, not perfect, but we pretty good, then that's good, you know, in my opinion, John, for as advice to you guys. But boy, you don't want somebody coming in and they've never made anything with it, because I don't know how you do design labels. To me, that, and maybe that's in there and I didn't read the RFP, John and Brandon and everybody, but I would just caution, you certainly don't want to develop design labels that can't make anything, right?
Yes. Yeah, no, those are good points. Yeah, it's kind of getting into the question of how do my testing coupons relate to my part, and different things like that. But yeah, that's points well taken. So I want to read this one comment real quick that I seen in here that was mentioned a while ago, or question: would alloys that meet SCC requirements at room temperature but fail SCC requirements after exposure to elevated temperatures due to sensitization still be considered for this call? That is a really interesting question, and I do not know, Crosby. I'll invite any of the government folks if you have any input on that or not.
Hey, John. Thanks for that. So good afternoon, everyone. My name is Kyle Cobb. I'm the deputy chair of the Joint Additive Manufacturing Working Group that is led out of OUSW R&E's Manufacturing Technology Office. And for the purposes of this project, I am the funding sponsor. What I will say, without answering the question directly, is the need for this material came directly from a variety of folks across the aviation community within the military services who are experiencing readiness and sustainment indicators for parts that are made out of this legacy alloy. So I will get with them and leverage their expertise to provide a question during the Q&A portion. Thank you.
Thank you, Kyle. All right, Nick, we got somebody else with their hand up.
Hi, John. It's Pan from University of Utah.
Okay.
I just want to ask one question also related to the geometry. For example, when you mentioned the fatigue test, right? Actually, my lab and my proposals discuss a lot of, standard abiding design, but a little bit different to the ASTM standards. Because, for example, when Greg talk about the applicability of the 3D printing parts, for example, sometimes we use 3D printing to create internal geometries, right? Then if we can build that internal geometry and we can test on it, I wonder this kind of shape flexibility for testing, will it be allowed? For example, usually people test the tensile bars, but because of we want to test the internal geometries, right? We may modify the tested coupon shape a little bit to make the through hole there per se. And we have this knowledge. So I just wonder whether this kind of flexibility will be allowed for proposal.
I would say, I would say that would be considered out of scope if someone did that in addition to all the things that would be required. It's probably, I guess, fine, but I want to make sure that the emphasis and the focus stays on just fundamental. What we're trying to do is we're trying to develop a statistically based understanding of just the fundamental material behavior, which is, I know a lot, there's a lot, there's both sides, but, the tensile tests and the basic tests, but they are, it's gathering fundamental information that people, a lot of people need to know on the design side, even if they have to factor in their design factors or knockdowns or whatever we want to call it, the safety factors.
I see.
After the fact, which is more design specific, getting into your, and I understand that, when you get into the complex geometries, your material performance can change locally.
I see.
But right now, for generating just getting a really robust understanding of the material performance in a fundamental manner, that's what we're focused on here for this. But thank you for the question.
Yeah, then just a quick follow-up is that this also means that when we test the coupons, then we need to actually apply polish to it before we test everything, right? We are not interested in like as printed surface roughness, how it influences SCC and fatigue.
So that's a really good question. We did not spell that out. That was something that was brought up. We didn't spell it out in the RFP. I think if there's you know, any potential seen by a proposer that would add value is say add as printed surface finish for different types of corrosion, how that would affect material performance. I think it's valid, but we want to make sure that this is focused on the current standards that exist
Sure.
for material testing. But what you bring up, I think, is a really important thing, especially for additive and getting into the, I wouldn't even say kind of forward thinking, but not even really necessarily. It's still present day. We can do a lot of complex shapes, features, and you can't do post processing or clean up those surfaces a lot of times, and they're just going to be as printed, and we got to know how they behave. So I think if someone wanted to add that in, and they fit it into all the other work that's going to be required, I think that could definitely be seen as a value add.
And sorry for taking so long, but you also mentioned we can look for like 7075 equivalent because we know 7075 is very tricky for SEC. By this kind of new alloy design, I didn't see adding like a powder side, specifications or requirements in this call. So is there any requirement, for example, we source some powders from the suppliers and because when we design new LPVF materials, I guess we really need new powders. That's my concern about how we connect the feedstock to the final, TRL ready information. Can you comment on this?
So the maturity of the powder feedstock itself and the availability of it. Yeah, that's going to be that. We didn't put any explicit language in there because it's kind of we don't know what we're going to get. So if there's formulations out there that are mature and available, they're just not, available on the market per se. But as long as the proposer can demonstrate that that somewhere they've been used and well understood and are essentially, for all intents and purposes, mature and can be made available to the community, because at the end of the day, it has, it's got to be available to in a broad sense, to the AM community or the manufacturing community. But yeah, this is I see what you're saying. Like now as far as developing new powders and then going through this whole entire process of creating a data set, I don't think that's necessarily feasible, but whatever powder is going to be utilized or material is going to be utilized, it would need to be pretty mature. Even if there's no, public spec available for it yet or not, that would all have to be, I guess, unofficially done, or ready to do that, implement that very quickly.
Okay, thanks, John. Yeah, that answers a lot. Thanks.
Okay. Thank you for the question. I think I've seen everything in the chat. Doug dropped in a really good point I forgot to mention, for the MMPDS allowables. So yeah, those aren't design allowables. There's material allowables that could be used for design allowables later on, but they're not really meant to capture like different nuances in the design phase. And I think, Doug, I seen a hand up. Oh, okay.
I just got to give a thumbs up. Yeah.
All right. Even better.
Related to the last person's question, if the goal is to eventually put this into MMPDS, all of the specifications have to be public.
Yes, great point.
So if there's no public spec for 7075 powder, you'd either have to write one or it couldn't go in there.
Yeah, that makes sense, actually. Thanks.
It's possible that there are some from ASTM, but I don't see any on the list yet for SAE.
Yes, very good point. All right, so that's all the questions I see in the chat. Does anyone else have any other questions before we wrap up? All righty. I guess I'll offer up the floor. I don't know if our government side had anything else they wanted to add, or
Yeah, nothing for me, John. Again, this is coming out of our office, and it's been sort of advocated for on behalf of the services. So this is important to all of us, and thank you again for hosting this project and this webinar. Over.
Thank you, Kyle. I appreciate you guys logging on. I know, they're at DMC. Everybody's busy doing a lot of different things, but yeah, thank you everyone for joining, and we will continue to capture questions and get that feedback to you in a couple of weeks. Thank you, and enjoy the rest of your afternoon.